Hello, Assalamu alaikum. Bismillahirrahmanirrahim. Today we discuss JNCIS switching module, we have completed routing section in JNCIS-SP. Today we discuss the second module. The second module is Junos service provider switching. Okay. So in Junos service provider switching, there is multiple module there or multiple chapter you can say. So first one is a course introduction, and then you will learn multiple topics from Juniper switching. Okay, so let's start. First one is course introduction. In course introduction, basically they are just providing some outline which will be delivered in enter the course. Okay, so first one, this module is Juniper service provider switching. And in Juniper service provider switching, we are discuss about LAN, local area network, layer 2 address learning, how to learn MAC address from end device, switch, just a learning process of switch. Okay, and then bridging and what is VLAN and how to create VLAN, how to configure VLAN, why we use VLAN, and number five is provider bracing. These are the outline or topics of Juniper service provider slicing. Okay, VLAN translation is binary protocol and Ethernet operation administration and maintenance, that is OAM. IRB interface, we are discussing about routing instance that can be virtual switch or that can be virtual, basically virtual switch. We are discussing also logical router, how to load balance and how to configure port mirroring. Okay, and another protocol is the multi-VLAN registration protocol. That this protocol is basically equal to BTP if you consider with Cisco switch. So MBRP is less used in our production, and then is the link aggregation groups or lag. You can say it's a LSCP, or last one is multi-chassis or MC lag. So these are the topics from Juniper service provider switching. So and just for Juniper end, you can you have multiple switching devices like EX series switches and QFX series switches. Also, MX device can act as a switch. Okay, so we'll learn about this. So if you learn the Juniper service provider switches, especially in JNCIS, just you have mm, you need some basic knowledge of OS model or TCP/IP protocol. That's enough. And if you have basic understanding of CCNA topics, you can understand everything from Juniper service provider switching modules. Okay, I think it will be very easy for you who is or who have knowledge equivalent CCNA switching. Okay, so this is the introduction of Juniper service provider switching. We see here how many topics we will discuss in our entire Juniper service provider switching courses. Okay, so let's start the second module. Our second module is Ethernet switching and layer 2. That means if we compare, or if you say Swiss is in OSI model, the layer 2, that means they are communicating based on MAC address. Okay, so there is multiple chapter or multiple modules in Ethernet switching. So first, we want to learn Junos West terminology and Ethernet LAN function first. Okay, So this is the physical or logical interfaces. This is the physical interface. You can see ZE means gigabit Ethernet interface. XE means 10 gig Ethernet interface. Logical interface, we can say logical interface dot one. If you add something, some value or some numeric number after the physical interface, that will be the logical interface. And we can use your inet for IPv4 and inet6 for IPv6. These are the IPv4 address and these are the IPv6 address. This is the basic nomenclature or basic understanding of Juniper interface and addresses. Okay, these are the interface naming. This is the main interface E0 by 0, and they have multiple unit here. Unit 1, unit 100, and those unit have IPv4 IP address. That means INET, and the INET 6. That is the IPv6 address. This is the just basic understanding of Juniper interfaces. Okay, so if you configure IP address in Juniper logical interfaces like unit 1, you can configure like this. So we have already configured mm, this configuration in routing section already. So in Ethernet, you can say Ethernet evaluation is now in topmost in Ethernet section. So in just if you just start from beginning, that was 10 Mbps speed in Ethernet link. Now our Ethernet link is one single Ethernet port can deliver up to 100 Gbps, 400 Gbps, and more than this. Okay, but in initial they are starting, the capacity is 10 Mbps. Okay, so this is the Ethernet revelation, and this is the overview. Okay, when Swiss is not coming in our network, in that time we're using hub, just sharing media, just like as a sharing media, multiple end devices connected with hub, and the main restriction was one user can communicate with others in a single time, no not multiple user communicate with simultaneously. That is the limitation of hub. uh, After that, we are introducing Swiss in our network. So Swiss have port in self port collision domain, and multiple user can communicate with others simultaneously in a same time or in single time frame. Okay, that means the Ethernet lens efficiency grows. Okay. So this is the simple question and answer section. Just checking the understanding of what I have discussed earlier. Okay. So first question is, so what is the technology used to avoid and manage frame collision? So to maintain or avoid the frame collision, we use CSMA or CD. So this is not using now. We are using switching infrastructure now. Okay, and some of the industry or some of the organization use full layer 3 network, not using the layer 2. Okay. So second question is, what are the characteristics of Ethernet LAN? So Ethernet LAN, basically we use the share the medium. Basically share the connect multiple device with switch. Okay, because router have port limitation, we are just expanding the port capacity using the switch. So uses shared medium with a single collision domain, and another characteristics is uses unique identifier for is not for identification. That means one and device is connected with one port, and they have unique ID. That means MAC address, and switch learn those MAC address just from a specific or individual port. Implementing layer 2 learning and forwarding. Okay, layer 2 learning and forwarding. The two topics are two words here. One is learning. Learning basically when you just install the switch, just consider one end device is connected with one single switch port. Like you can connect laptop or desktop or printer like this. Just switch basically learn connected device MAC address for connected device MAC address, and this MAC address is stored in their bridge table or MAC table. So this is the learning process. Okay, this is the learning process. And the forwarding process is when switch getting frame in one incoming port, just disclose this frame and see the source MAC, destination MAC. If destination MAC is in MAC table, they forward those frame the specified MAC table outgoing interfaces. This is the forwarding options. So this is the way of learning and forwarding of any specific switches. Okay, so this is the example, or this is the you can say this is the switch. So there is two VLAN configured. One is VLAN 100, another VLAN is 200. There is two interface. One interface is Z0 by 0, another interface is Z0 by 0, 0 by 0 by 1. So consider here. So this is this interface. This is your interface. Just this interface is unit 0, and this interface is family bridge. So this switch is MX. This is basically not a switch. This is not a switch. We consider here MX series device. It can be MX204. It can be MX240. If you configure this router act as a switch, you can just configure those interface like this: set interface unit and family bridge, and just configure this. If this interface is access, configure the interface mode is access. If this interface act as a trunk port, you configure interface mode trunk. The access port means single VLAN can communicate within this port. If you configure the trunk port means multiple VLAN can communicate through this port or within this port. Okay, so first consider one switch. Okay, this is the another switch. So you consider here one PC is connected here. This is PC1, another PC is here. This is PC2. Like this PC1, PC1, P1, and this is P2, PC2. This is the switch 1. This is switch 1 and this is switch 2. So if I configure and this switch 1, this port will be the trunk port, this port will be the access port, this port will be the trunk port, this port will be the access port. If I use here one single VLAN, like VLAN is 10, first of all, we create this VLAN in switch 1, also create the VLAN in switch 2, allow this VLAN in trunk port, and assign this VLAN 10 in access port. This is the basic functionality. This is the basic functionality when PC1 uh, mm, after configuration PC1 can communicate with PC2. So this is the example. Okay, you consider this is a switch, this device also a switch, this device also a switch. That's why they configure this device as a trunk, this device as a trunk. Okay, and this is the way of configuring the VLAN. This is the way of configuring the VLAN. If you use MX series device, if you use EX or QFX series switch, the VLAN configuration is different. VLAN configuration is different. So bridge domain, you set the bridge domain name and set the VLAN ID. Also include the interface. Include the interface. This is basically sub interface. This is basically sub interface. This is the another VLAN. VLAN ID is 200 and this is the sub interface. So if we configure IP address, management IP address in switch 1 and management IP address in switch 2, we use here IRB interface. We use here IRB interface. Okay. Later slide, I will show you how to configure the IRB interface to log in those switch management VLAN IP addresses. Okay. So this is the basic consideration when you deploy switch in your network. Okay. Bridging domains and learning domains, and this is the two things. One is learn MAC address and associated ports, and store this information in their bridge table or MAC tables. Forwarding means forward packet out of the proper egress interface toward the destination. It's depend those destination MAC address is in their MAC table or not. If is in their MAC table, they will forward. If not available in their MAC table, those packet will be flagged. Okay, or broadcast time. So third is flooding. This is the third step is flooding. Replicate packet out of other ports for unknown destination MAC address, also used when passing multicast and broadcast traffic. So consider here, and here you have two switches. You have just consider you have two switches. You can take two VMX devices. Just consider here four VMX devices. Default interface and default RAM, just save one. Consider it's a PC, and consider here it's a switch. Okay, like SWI switch 1, and just changing the image for better understanding. Okay, and the switch router server switch. Consider this switch SW. It's a switch 2. Changing the icon. This is switch, and considered it's a PC. Okay, for making all lab. Consider it's a PC1 and it's a PC2. PC2 and the image, okay, done. It's a PC2. So this is switch just connecting two switches. You can select this interfaces, okay, and connect another interface with PC like one, and you can consider here one. This one, one, okay. So consider a single VLAN. The VLAN ID is, consider here VLAN ID is 100, and you use subnet here 192.168.100.0/24. Okay, this is your VLAN and this is your network. PC1 IP address, consider here. PC1 IP address is 101/24, and PC2 IP address is 102. So see here, this is a Swiss. This both are Swiss, and it's a PC. Okay, this two PC in a same subnet, and this same subnet under same VLAN. Okay, if I configure this device as a Swiss, also this one, so we can say PC1 can communicate with PC2. Okay, PC1 can communicate with PC2. The consideration is this, just configure this port as a access port and VLAN ID 100. This port configured as a access port and associate VLAN is 100, and configure this port as a trunk. This is the requirement to communicate with PC1 to PC2. Okay, so just starting this lab. Okay, so third item is flooding. When flooding is happened, when it just Swiss getting the incoming frame, their incoming frame, they are getting source MAC address and destination MAC address. If destination MAC address not in their Swiss MAC table or base table, those frame will be flooded. Or if Swiss receive unknown multicast or unknown unicast MAC address, that or broadcast traffic or broadcast MAC address, those frame also will be flooded to another interfaces except incoming interfaces. This is called the flooding. And filtering limits traffic to its associated network segment. We can apply filtering based on VLAN or based on port. Okay, so if we apply filtering based on source or destination MAC address, it really used. So you can say you can filter your MAC address. Okay, and the last one is the async. Async means just uh, after finishing the learning process, After finishing the learning process, they Swiss basically stored the MAC address in their MAC table for certain time. The default timer is 300 second. Okay. If end device is continuously connected with the switches, those entry is in their MAC table. There is no issue. If the end device is disconnected for certain time, they keep their MAC address for 300 seconds or 5 minutes. After that, they will refresh the MAC table. This is called the aging. Okay. So next one. This is the sample example of frame. This is the frame format basically. This is the frame format. So in a frame format, CDA. DA means destination MAC address. SA means source MAC address. So it's a MX240 router, but act as a switch. Okay. This two interface, one interface is 0 by 0 and another interface is 0 by 0 by 1. Multiple PC is connected with this device and this is the MAC table. This is the MAC table. Z0 by 0, they learn two MAC address from A1 and A2. From Z dash 0 by 0 by 1, from this port, they learn two MAC address B1 and B2. Okay, so consider here if incoming, just consider incoming frame is coming from A1 to B1. Consider here A1 to B1. So when coming frame from G0 by 0 by 0, they just open this frame, check the MAC address table. See the B1 MAC address, B1 PC MAC address is this. B1 PC MAC address is this. So Swiss forward this frame towards this interface, okay, because this is known frame, this destination is known, that's why this frame will be forward, and after learning process they will populate the MAC address table, and MAC address table is store the interface incoming frame interface and the respective MAC address of end device. So this is the MAC learning way or MAC learning process. Forwarding known Unicast frames. If MAC address is known, the frame will be forward. This is very simple. Okay. And flooding broadcast unknown unicast and multicast frames. This MAC address is broadcast. All is F. This MAC address is broadcast. So if Swiss getting one frame containing destination MAC address is all F, they just receive this frame and deliver or forward every port excepting the incoming port, they just forward this frame all their switch ports. So this is the flooding process. Flooding process happened one broadcast frame, number two unknown unicast that is not installed in their MAC table or multicast frame. This is the command show bridge MAC table saying the MAC address table of switches. This is the MAC address. This MAC address is learned dynamically. D means dynamically, and this is the respective interface. Clear bridge MAC table. If you want to clear MAC table for certain time for checking, basically we clear MAC table for checking quickly because the MAC table after learning MAC table is stored the MAC address for 5 minutes. If we want to take decision quickly, then we can clear the base MAC table. Or in Ethernet, EX or QFX switch, this command will be clear bridge, not bridge MAC MAC table or MAC address table. So this is the similar command, show base MAC table, clear base MAC table. You can clear MAC table for a specific interface, for a specific VLAN. Okay. MAC address learning and forwarding. This is the default statistics. Set bridge options, interface. This is the additional options. So if you want to limit the MAC table size, if you want to limit the MAC table size, so you can set MAC table size in bridge options. Under bridge options, you can set the MAC table size. Okay. If this table size exceed, your packet will be or your frame will be dropped. You can set. By default, MAC table size is depends on model basically. Okay, please mute yourself. Show layer to learning interface. This is another command to see the MAC address historical information. Aging interval 300 seconds. We already share with you. MAC learning, default MAC learning is enabled. And MAC limit count, this is the MAC limit count. 39, 32, and 15. This is the MAC limit, maximum MAC limit. Okay. So after completing this module, we are just checking our understanding. What makes bridging different from routing? Bracing means it's switching. Bracing means basically it's a switching, and routing means just your port will be in routing mode, and different network will be communicate with different interfaces. Okay, but in switching they are just communicating based on MAC. Bracing connects to separate networks through inter-VLAN routing. Okay. What are the advantages of using bracing in 800 to 1D 2004 standard? Isolate the physical layer, learns and maintains a forwarding brace table, performs intelligent forwarding decisions. What mechanism does the switch use to deliver traffic while passing it from an incoming interface that leads to the destination? This is the forwarding mechanism. And this section we will discuss layer 2 firewall filters. We know about layer 3 firewall filters. In layer 3 firewall filters, we can match source address, we can match destination address, we can match source port, destination port, source protocol, destination protocol. So in layer 2, you can also apply layer 2 firewall filters. Basically, it's work with based on port and based on you can say source MAC address and destination MAC address. You can also apply this filter in VLAN interface also. Okay, this is the sample example. set firewall family breeze, filter, then filter name, then filter first is messing and then is action. In firewall filter, there is two option. One option is you mess something. You can mess source destination address or protocol or port, and you can set the action. Action can be accept, action can be reject, or other than this. So this is the some this it's an example. Okay, it's an example. Just creating the filter and apply the layer 2 interface. Family bridge means it's a layer 2 interface. Okay, and you can apply also in forwarding options under the bridge domain, under the bridge domain. But this rarely use. In layer 2, we are not considering filtering basically. Okay, so if you want, then you can study and you can apply this. Okay, sure, Aaron. Which factor is incorrect during the process of the filter accepting and discarding packets? Filtering, accepting, and discarding packets. Which factor is incorrect during the process of the filter accepting and discarding packets? We can apply the filter under the base domain, and we can apply direct layer to or bridge interfaces. So the incorrect option is 800. Which modifier is used for multi-field classification of class of service? Basically, when we apply the class of service or quality of service, we are just calling forwarding classes. Forwarding class, by default, there will be four types. Number one is the best effort, assured forwarding, expedient forwarding, and network control. Okay, so if we want to modify or if we apply quality of service in our devices, we can use forwarding class. Okay, so this is the layer 2 section. Basically, Ethernet switching and layer 2 section. Here, just we discuss basic function, basic role of switches. Basic role is how to learn MAC address. Number one, how to forward the frame. Number two, how when flood the frame. Number three, and last one is aging. After learning how much time or how to store the MAC table in the memory. So this is the basic functionality of Ethernet switching. So this is our lab. Today we just configure these VMX devices as a switch and communicating PC1 to PC2. This is our today's lab. Okay, so you can take another device. You can say Juniper. You can say Juniper EX, or you can take QFX. So in our next class, we will take QFX for um, checking the switching functionality. Today we check with VMX. Okay. So first one is just go to switch one. Yes. Well, okay. switch 1, and this is switch 2, it's PC1, and it's PC2. So root 1, 2, 3, CLI, edit, root 3, CLI, edit, PC1, root 1, 2, 3, CLI, edit. Right. Yeah. So this device have some default configuration. First of all, we want to remove this one. This device name will be Swiss one. Stop is Swiss one. Remove logical router 1, and logical router 2, and the management interface. Delete the management interface. Okay, this is Swiss 2. Swiss 2. Delete logical router from here. Let's see 2. Okay, and set host name. It's a PC1. It's a PC2. Swiss 2. Okay. Delete logical router R2. Delete. Okay. And delete the management interface also. No need, no need this configuration. Okay. Commit. Commit. So this is Swiss 1, Swiss 2, and this is PC. Okay. So in Swiss 1, we configure this port as a layer 2 port, and configure this port as a trunk port. Okay. So set interface GE dash 0 by 0 by 0 unit 0 family. See here, family bridge. Bridge means layer 2 bridging parameter. Okay, that means layer 2. Basically, this router port is a layer 3 port. Basically, layer 3 port. We configure this port as a layer 2. So, bridge. Then, interface mode. This port interface mode is trunk. Okay, this interface mode is trunk. So what is the error? Interface mode trunk must be defined either VLAN ID list or inner VLAN ID. VLAN ID list or inner VLAN ID list. That means we have to define the VLAN ID. We have to define the VLAN ID. Which VLAN will be allowed through this trunk port. Okay, so consider here we are showing here VLAN 100. VLAN 100. So you can say here, you can configure here VLAN ID VLAN ID list. You can say it here 100. So commit check. Now it's okay. Your configuration is okay. Commit this one. So similar configuration. Firstly, we define this port as a trunk port and allowed the VLAN. Okay. Same configuration will be in switch 2 and interface also same. Commit. And this interface is connected with PC1. So this interface, you can configure this interface as a access mode. That means set interface G is 0 by 0 by 1 unit 0 family brace interface mode. This port will be access. Comment this one. Same error. Okay, so you have to mention the VLAN ID. Which VLAN ID will be associated with this access port. Okay, so in that case, you can create the VLAN. Okay, bridge domain name, bridge domain name. Like I can say bridge domain for VLAN 100. Then bridge domain options, we can use bridge domain options here. Then you can we can use domain type of bridge domain. Type of bridge domain, it's bridge, default bridge basically, bridge. And the VLAN ID will be you can set the VLAN ID. VLAN ID will be 100. VLAN ID will be 100. Similar way, you can configure another VLAN like VLAN 200. Set here 200. So you create here two VLAN. You set here two VLAN 100 and 200. Now associate this VLAN with access port. Bridge. Then mention the VLAN ID. Mention the VLAN ID. Bridge then mention the VLAN ID. VLAN ID and VLAN ID is you can set the VLAN ID. So VLAN ID is 100. Okay. So commit this one. Now it's working. So display set. So this is the configuration of creating VLAN. Okay. Creating VLAN. So just copy this one and access interface. Okay. Run show base Mac table. Run show base Mac table. There's nothing. Okay. There's nothing. So PC1, you consider it's not a router, it's a PC. So set the IP here. Set interface GE dash 0 by 0 by 1 unit 0 family inet address. My address is 192.168.100.101 slash 24. This is my address. Connect this one. Show display set. Similar configuration in PC2. The IP will be 102. Just set the IP address. No need the gateway here. Okay. No need the gateway. So comment this one. So try to sending packet from PC1 to PC2. So my IP is 1 and this is PC2. So check the MAC table here. Run show bridge MAC table. See here, the VLAN is 100, the bridge domain is 100, and you are getting the MAC address. And MAC address learning is dynamic. Dynamic learning the MAC address through G0 by 0 by 1 and G0 by 0 by 0. Okay, so now comparing this one, run show interface G is 0 by 0 by 1. 1. So see here, I'm in PC1. PC1 Z0 by 0 by 1 MAC address is this 6F colon 01. 6F colon 01. This MAC address is coming from G0 by 0 by 1. This port. Okay. Another MAC address is coming through G0 by 0 by 0. This MAC address is basically PC2 MAC address. So confirm this MAC address from PC2. See here, the MAC address is this one. The PC2 interface Z0 by 0 by 1 MAC address is FA colon 01. FA colon 01. This is the MAC address of PC2. And they are communicating with each other. So this is very basic. Okay. Any query? Any query of today's topics? Layer 2 basic function. We are just configuring today layer 2 basic functions.
Clear.
So that's all for today. Just as you are late today, right? Just as we are waiting for you, but you are coming late.
Someone asked a question in chat box.
Okay. So the question is, what is VLAN list? VLAN list just if you want just compare with another device. Okay. In transport, in Cisco device, you allow VLAN, you just allow multiple VLAN at a time. Multiple VLAN at a time, like 100 to 200 or 500 to 700. So this is called the list. This is called the list, nothing else. And if you want to mention single VLAN, if you want to mention single VLAN, you can use VLAN ID. If you want to mention multiple VLAN, you have to use VLAN list. Clear? Understand? Perfect. Like this is the trunk port, correct? This is the trunk port. So in that case, you need to add 200 also, 200 also, or you can say 100 to 200. You can say, okay. So this is the range. Individual VLAN IDs ranges separated by commas. Oh, ranges separated by commas. That means if I add 200 and displace that, after this, we need to add comma. Okay, I remove this one and commit. Yes, it's working. Display set. VLAN ID list 100 200. So if I make like this, VLAN ID list multiple like 300, 300 comma, no, 300 comma, 400, no, 400, yes. So add this one, error value must be villain number or a range in the minimum villain, maximum villain. That means where if I take this under third bracket, also getting error, just skip the comma, not getting error, commit this one, perfect. Multiple villain, you can set multiple villain. Okay, if I said range, if I want to set range like 500 to 700 and commit this one, perfect. So this plus that, got it? List. Okay, already I understand. This is the list. Okay, unit allowed multiple villain in trunk port. That's why I use here villain ID list. Okay, so I think that's all for today. So today we have completed course introduction, Juniper service provider switching, and Ethernet switching and layer 2. So in our next class, I try to discuss virtual switches and VLANs and IRPs. In our slide, they are showing basically MX series devices. They are showing lab from MX series devices, but in practical, we use AX or QFX series switch from Juniper. Okay, so this lab is okay for our syllabus. We will continue with this lab. Beside this, we will take QFX in next session. Okay, that will be more professional, I think, and you will get more learning from that. Okay, thanks for today. Allah Hafiz. Record.